Hey Doug, so try and give you as clear of an explanation of how all this works as I can. So when you're looking at your pressure transducer here, you have your two outputs and they are completely independent of each other. And so their configuration and whatnot all happens independently. So when you're looking at this set point 1 and reset point 1, that's just for output 1, has no effect on output 2, and the same thing goes for SP2, RP2, and your delay set reset and your output type. So first thing to look at is the output type here. We've got HNC, which is hysteresis, normally closed, and then its opposite, hysteresis, normally open. All that's doing is saying when this one switches, it's either normally open or normally closed, so that'll just be upside down either way. So when your initial system startup occurs, you start down here with your dump valve closed, your pump turns on, and you've obviously got zero pressure, and then your pressure climbs up. When it reaches SP1 and SP2, you set them to be the same value. Once it hits that point, your pump will start counting down at 60 seconds, and your dump valve will go from closed to open. So now your pump is running and you're recycling everything back to the tank. After 60 seconds, your pump will turn off and your dump valve will still be open, trying to return fluid to the tank, but obviously there isn't any because the pump's off. As you start to use fluid, your pressure will drop and you'll go back through RP2. So that's reset pressure 2 for output 2, and your dump valve closes. That has no effect on this, being that's the other side of a check valve. So then you continue to use pressure out of your accumulator, and eventually you'll get down to reset point 1 and your pump will switch on. So that's your reset point 1 set at 1500 psi. SP1, SP2 is your 2500 psi, and RP2, I'll put that at 105 bar, which is a little bit below your normal pressure, but that is an arbitrary value, just so long as it's a little bit below your set point and above RP1. So yeah, our pump turns back on and our line pressure returns up to its maximum value. That starts our clock again and opens our dump valve again. Time goes on, that switches off, you use a little bit of fluid, that triggers this valve down here to close, but your pump stays off and your accumulator is responsible for producing an output from then on in, until of course you use more fluid, and then eventually your pump will start up like over here. So then on here we've got a new cycle. So starting from cold, you turn the whole system on from zero pressure, your pump starts, your dump valve is closed, you start using the fluid before it ever reaches its set point, that very top line. That causes a drop in pressure because it hasn't reached SP1 or SP2 up the top here. Nothing happens with your outputs, they just stay there until you stop using heaps of fluid, allow the pressure to climb, and then your timer starts and your dump valve opens. So this will all produce the desired output for the system that you like, that you want, and do it with a minimum of components. So with this here, so you're normally open versus normally closed. I've actually drawn it as normally closed here, which is what I've done here. So this valve is in its normally closed position. If you used a normally open valve, you just change HNO to HNC, and that's about it. And same thing with your pump. If you want the pump to turn on when this is in a low state, then you just change that from HNC to HNO. And yeah, so this this is your hysteresis. Basically it's saying that it will only turn off when it reaches a high point and only turn on when it reaches a low point, and it'll bounce up and down within that window. Anything else basically just gets ignored. If it doesn't reach that window, so if it doesn't reach SP1 up here and then it goes below RP1, doesn't matter. Pump's never been turned off, so there's nothing to reset. Hopefully that helps. If you have any questions, feel free to ask. Also, interestingly, these solenoid coils, if they're rated for 12 volts, have a look at the data sheet for them. Sometimes, or most of the time, they'll be able to accept a lower voltage than that. They'll have a minimum working voltage of, say, maybe 11 volts for a 12 volt coil. If you run that at 11.2, 11.3 volts, you substantially increase the lifespan of this thing. So you might go from a 5-year useful life to a 50-year useful life. That's maybe something worth considering as well. I'll catch you later, mate.